Welcome, this is the IM2 video lecture on the transforming quadratic function, part 3. The learning target is for you to understand how a parabola transforms. In this video, the success criteria will just be describing the transformation of a parabola. We're going to start with looking and reviewing our core concepts that you should have from the entire video series from part 1 and part 2. The vertex form for the quadratic function can be defined by this. F of g of x is equal to a parentheses x minus h squared plus k. Each one of these variables represents something very unique. The a term, sign, tells you how it opens. It opens upwards when a is positive, and it opens downwards when a is negative. The value of a describes its dilation, or its size change. When a equals to 1, that value, that parabola stays the same. If the a is greater than 1, there's a vertical compression, which means it comes in and it gets compressed. If it is a fraction, we have a vertical stretch. That fraction is in between 1 and 0, like 1/2, for example. That is a vertical stretch. It gets wider. The k value tells how the parabola moves in the up and down direction. Adding k will move it up, subtracting k will move it down. The h tells you the horizontal translation, which tells you how it moves from left to right. Subtracting h will move it left, and adding h will move it to the right. Let's look at our example here. Here, I would like you to describe the transforming parabola. The parent function is given here as x squared. Then you have this parabola. Describe this transformation using words. Step 1 is to label the variables for the transformation. A, h, and k. To make this easier, I wrote vertex form right on top of it. Notice here, once I write it on top of it, you can see what each letter is. So, A is 1, because A is in front of the parentheses. H is right here, which is just the 4. It's minus h, minus 4. So h is 4. And your k is out here, which is 1. Now we're going to use our core concept words to talk about it. When a equals to 1, we say there was no flip and no size change. When h was equal to 4, that is right 4. Okay, h tells us it's moving right when it's positive. And then k equals to 1, that means up 1, because that is what the k is here. So, there you go. You just have to be able to label the variables, then describe which transformation those variables refer to. Let's look at this now. The new function is negative k, negative parentheses x plus 4 squared. Describe the transformation using words. My a, which is in front, is a negative 1 right here. Okay, negative 1 for the a. Now the h, notice this is minus h, so this has to be a minus. Okay, so there has to be a minus in front. For there to be a minus in front, that h value has to be a minus. Okay, because a negative and a negative, okay, will multiply to make a positive. That's why the h variable here is negative 4. Okay, because notice it is x minus h. Okay, but here it was x plus 4. I had to make this a negative by making the h value a negative. So it becomes x minus parentheses minus 4. Because when I multiply these together, it becomes x plus 4. Okay, that's the explanation for the math here. Good. And my k value, which is out, there is nothing here. So it's a plus 0, so I'll write k equals to 0. So when a is negative, we saw that that is a reflection over the x-axis. And when my h here, it's a negative 4, that means it's 4 units to the left. And my k here is equal to no up or down. To double check, you can always graph it on decimals. So here I have decimals up, and I'm going to graph it to double check. Here I have g of x is equal to negative parentheses x plus 4 squared. Notice, did this match up with my description? Did it reflect? Here's my original. My original was, let me graph my original here. The original was f of x equals to x squared. So my original was this green. So did I reflect it over the x-axis? Yes. Then did I move 4 units to the left? Yes. Okay. This is how you can double check your work, to graph it and to see if your description matches up. Now you could do some of the practice problem. Again, same process here. Describe it after you find the variables. Let's give this a try. Three. I labeled it. That's vertex form. So A here is the number in front, which is 1. H is 5, and K was negative 7. A equals to 1 has nothing with it. The H equals to 5, that means right 5. And k equals to negative 7 means 7 units down. Let's check it. Okay, I went 5 units to the right, then 7 units down. So that is correct. 4. A was negative 1/3. H was actually negative 4, because remember, in vertex form, it's x minus. Okay, so it's a negative 4. And my k is a 2. A equals to negative 1/3. The negative means it reflects over the x-axis. The 1/3 means it's a vertical stretch by a factor of 3. That vertical stretch is because it's a fraction in between 1 and 0. That h of negative 4 means 4 units left. And the k value of 2 means it's going up 2. Let's see if that makes sense. From green to purple, we saw that it did reflect over the x-axis. It did get larger by having a vertical stretch by a factor of 3. 4 units to the left, and as well as 2 units up. 5. The A value is 2, H is 10, and the K is 4. A equals to 2 just means it is a vertically compressed by a factor of 2, because it is a number greater than 1. H is 10, that means it goes to the right 10. And k equals to 4, that means it goes up 4. Let's graph it. So it goes from green to orange. Okay, my parent to my new function. So it got vertically compressed by a factor of 2, so notice it shrinked. H means it went to the right 10, and it went 4 units up. There you go.